I think this is working now, and we're gonna go start with the Leetcode session, solving Neetcode's list on graphs, and we're gonna try to solve as many as we can in the next hour of me like doing this stream. So we'll see what happens with the explanations and everything. So we got clone graph here. So we have clone graph here. So we're gonna begin some graph and we're gonna make a copy, an exact copy of it. It's not like node copy, it's like actually like memory address copy. And to do this, I think what we do is we have like another map up here. So we'll have like a 1, and then we'll say like, oh, well, is 1 in this map? It's like, oh, no, it's not. Okay, cool. Let's make the 1 and create that new node. And it's going to point to the new node. What is up, Rollo Gomez? Do you have any other interviews coming up? No, I'm not applying to any jobs actually at all. So I don't have any. I could have some. I have recruiters still reaching out to me. One reached out to me for like some AI, the founding AI engineer or something of like some startup. That's Y Combinator startup. But I'm not doing any interviews, so I'm okay. I'm good. Just gonna do this business thing. I actually read a thing on stream yesterday, and it was about a guy who like quit his Google job to like work. I thought it was pretty cool actually. I guess they're probably gonna be slowing down on this Leetcode stuff, but um, this one was like really good article. But I mean, this is like pretty much embodies my mindset right now, honestly. But he's been like solo doing this. He quit in 2018, but he's been solo building his own business since then. Yeah. So for 6 years about. But yeah, the solve clone graph, we'll just create like a new map and we'll say, okay, 1, we can attach that node to that one, to its parent. And then same thing when we jump into 2, we're like, okay, well, we need to keep track of 2's parent, which was 1. And make sure that, okay, is 2 to exist in the map? And so we set it to 2, exists in the map, points to a node. And then now we just need to connect everything to it. So we'll connect everything when we traverse children. Is that fine? When do we do it? Ugh, it's so confusing. Actually, I don't even, what is typing optional thing here? Okay, sure. I'm gonna delete that. Actually, maybe I need it. .neighbors, whatever. All right, we'll try to code this out, but new node, like node val to new node or something. I believe these are all, we call it like a node. I believe these are all distinct, right? The value is unique, so these are distinct values. Cool. What this means is we can do, this timer is wrong. What it means is we can do just DFS. I don't think I need to have the parent here, honestly. I think I can just get away with just the node, because the thing is, if I go here, I can just go through all its children, which would be 3 and 1, and just set them. And even for 1, I can just set it with 2 and 4. With 2 and 4. So I don't need to pass in the parents. So then we'll just say like if node.val not in val to new node. Well, then we need to make that new node. How about this? Val to new node. I mean, honestly, just val to node. I would prefer that, but there's like node.val. And actually .get node.val, and then none. Just pass in none. So now we can just say like if not new node, then we know it doesn't exist. And so now we can say val to node at node.val is equal to node. And we'll pass in the value here, node.val, like that. So we'll give it its fresh 1, nice and fresh. And then I want to change the name of this one to just node, like that. And we want to do is set new node equal to val to node at node.val. So set the new node. Okay, now what we do is just go through all the children. So like for, and at the very end too, we're gonna return new node. And then we'll go through the children. So then for node, or for child in node.neighbors. Then we'll say child node is equal to DFS child every time, and now we can just say new node dot neighbors dot append child node. And this works. Now we just need to keep track of the scenes too, so we don't infinitely loop, I think. And like if node in scene return, and then like scene dot add node dot value, like that. And I think this is like pretty clean, probably, honestly. So return DFS of like whatever the node is. Because with this one, what we're doing is we're taking this, we're checking the map. Okay, what is it? If it's not there, create it into the map, jump inside. Oh, is it, what is it? Okay, create it, jump into the map. Okay. Call it onto its node. So in this case, like we see 2, and then we're like, okay, 3, whatever, 4, whatever. But then for 2, we end up getting back to here, and we're like, okay, for this 2, the 1 we've already seen before, so we actually just end up returning. But we want to make sure to return the node of 1. That's something for sure we want to do. So we should return val to node at node.val. If we've seen it, just return the copy of the node so that we can start setting it here. And then this one will give us what we need. Yeah, I like this. I like this. Okay, cool. None type has no attribute. Okay, let's see here. If not node, return none. Like that, yeah. Cool, yeah, so this works perfectly. And we did this one pretty fast, about 4 minutes, 30 seconds-ish. Maybe about 6 minutes, actually. Like real time, 6 minutes. So this used to be a problem that was like pretty difficult. So it's good to be able to code it up pretty fast. Okay, we're speedrunning, trying to get through as many of these problems as we can within the 1 hour. So maybe I can do 6 minutes per problem. I don't know. We're gonna want to refresh this, right? So you're given values in by n grid. Rooms initialized with 3 possible values: wall, a gate, or infinity. Infinity means an empty room, which means I guess we can walk there. Fill each empty room with the distance to its nearest gate. If it is impossible to reach a gate, then we should fill it with infinity. Okay, cool. So this one's like super simple, like just basic BFS problem where we just start at the gates here and we start our traversal. So we're like, okay, this one is 1, 1. Like each time they just kind of all move up 1, and then we keep going and increment their counters basically until we can't move anymore. And then we just like return whatever the rooms are. And so like anytime we're doing like these directions, moving up, down, left, and right, we just create like a directions array. 0, 1. And let me actually start the timer here so we can actually get this some time going. But the idea is you just store these positions and we just BFS out as much as we can until we like can't see anything. And we just know if we can't move there if it's not infinity or 0 or -1, right? Like if it's not infinity, actually we can't move there. So that'll be that. So then like this 1, 0, -1, 0, 0, -1. I'll do 4, not 4, not even 4 yet. Actually, yeah, we can. Length of rooms, n is length of rooms at 0. So we need to collect all the walls. Where are the walls at? And then we need to have our queue, which is going to be a deck in Python, of course, right? But we need to go through those for I in range M, for J in range N, and then we'll do rooms at I at J. Hold on here. Yeah, if the value is a 0, then we have our thing, which is appended. So we'll append the location of it, just like that. And now, once we do all of that, we're going to have locations of all of them. So we can say while q, and then we can keep track of the row, the column, and the steps so far. That'll be q.pop left. And then what we'll do is we can check for scene. If we've seen something before. I don't know if we actually need it, because we will be modifying the actual grid. So that's probably okay. And then instead what we can do is just say rooms at R at C is just equal to like steps. In this case, it would be 0. In the initial case, it's 0. And then we just go through the children. So for dr dc in directions, nr is equal to r plus dr, nc is equal to c plus dc. If 0 less than or equal to in R, we're going to make sure that we're going to check in bounds. Are we in bounds? If we are in bounds, then we can potentially move there. And we can also move there if in R and C, that new position is going to be equal to math.infinity. Is it always math.infinity or negative? Infinity means empty room. We use the value 2 to the power 31 minus 1. Okay, like why not let's just say inf. How about that? If it's equal to inf, then we'll just add it. So q.append rc. And then we'll add in steps. We'll increment the steps that we've taken, and then at the very, very end, just return the rooms, because we're modifying the rooms directly here. And this should be fine. This should work actually perfectly fine, I think. I'm just going to submit it. And I misspelled rooms, so that's cringe. Let's run it again. Okay, we are infinite. Didn't expect that actually to go infinite, because we are checking here and we're only modifying these. Oh, it's because we also can't move through walls. But that's actually fine, because we only move if it's equal to inf. Actually really surprised this failed. What did I do wrong? I mean, I could have a scene, but I don't think it's needed, because there aren't that many infinities that it could go to, especially when I declare it here. And then we're checking bounds. Oh, it's R, rip, typoed it, nr, nc. So that's the issue. nr, nc. If it is impossible to reach a gate, it should be returned with negative infinity. Or with infinity. No, this is fine. 1, 2, 3. 1, 2, 4. Why is it getting 1, 2, 4? Oh no. Four? Really? Problem is, this is also hard to debug, but like, this feels fine to me. This feels super fine. I mean, if I really, really want to, I just say minimum rooms at RC with steps, but like, that's not even Like, is that really? Like, really? It's, I guess I need the scene. This actually might TLE because of that scene issue, or it's just gonna be really slow, but yeah, because it's double counting them, which I didn't think it would do because of this. I guess if they're tied or something, if they're tied, then it will. But well, we would have a scene to prevent this, and then just say like if RC and scene, like just continue, and then do like scene.add r RC if we want to actually do this faster. It helps the speed massively. Cool. So that's the solution to this one. Just standard BFS, super standard BFS. Go through the children. You know, again, children are a little bit different because we're going up, down, left, right. So we can just create a directions pattern, and that makes it easier for us to go up, down, left, right directionally, and have like an infinity constant that we have to find some constants to make the code a little bit cleaner and get this thing done in about 5 minutes. So that is that. Rotting oranges, I think, is like literally the same thing as the other one that was just there. I think it's like literally the same idea. Like you're given some in by in grid. You could have an empty cell. You could have a fresh orange, a rotten orange. Every minute, then orange becomes rotten. That is every minute a fresh orange that is adjacent to a rotten orange becomes rotten. You return the minimum number of minutes that must elapse until there is no more. So same thing. I think we just start with the rotten oranges, and they're going to infect like every minute, basically. So all the oranges will kind of collectively do an action. And unfortunately, there's only one here. It's just kind of bad, I think. But like, we just gather all of them up and then just like say, okay, this one's infected, and so now they need to chain over, and like they do 4 directionally or whatever, and then 4 directionally, and then we keep doing it until we have no more, until they've all been taken. And okay, and then how do we know when all of them have been taken? It's going to be when we can't do DFS, like, or BFS, when we can't do breadth of search anymore. So actually what I'm going to do is I'm going to take this code here, and we're just going to slightly modify it to match with this, because there's no reason for me to write the same code for these problems. We still want the directions, right? Infinity goes away. We don't really care about that. Instead, we're doing 0, 1, and 2. But rotten oranges can only really jump to a 1. So like in this case, we would just say like 1. And then instead of returning the rooms, we're just going to return I guess the steps, like the total steps that we see. So it'll be like answer is equal to 0, and then just like answer is equal to max of answer and steps, something like that. And then we can just modify these and set them to a rotten orange every single time we move. And then we want to take and collect all of the rotten oranges, so we change it to a 2, because all rotten oranges are 2s. And go through, collect all the rotten oranges, and then go through and infect all of the ones that they're touching. And okay, so there is a possible thing where it's impossible, in which case we need to actually count the number of oranges that we've touched. So we're gonna have like total oranges, or total like fresh oranges. Maybe just total oranges is equal to 0. And then like elif rooms at I, j is equal to 1 total oranges plus equals 1. We'll have the total oranges, and then what we'll do is we'll say like total oranges minus equals 1. And then like if total oranges is not equal to 0, then we return -1, because we know we didn't see all of them. And I think this is fine. I think it's fine, right? Same thing, just DFS through, count the oranges. Let's say we've got like 1, 2, 3, 4, 5, 6, 7. Now we have 6, infect, 5, 4, 3, 2, 1, 0, right? With effect, yeah. I like it. And something we're doing rooms and not grid, so we can say just rooms equals grid. Yeah. And this code works. Got it on the 4-minute mark. Thanks to just copying and pasting the other code that we had, but the general idea is to just start here. We need to count all the oranges in case that it's impossible, and just BFS through and just take the time, let them tick. If you were to actually draw out like what BFS looks like, is that it looks like you've got like one orange here, like one orange here, like one that's rotten here, and then at each step like you're going like 1, 1, 1, okay, 1, 1, 1, okay, 1, 1, 1. They're all keeping track of the data of like which one's like the largest, 2, 2, 2, whatever, and then 2, 2, 2, whatever, and they just keep kind of spreading, and then we eventually get like some max number that's there. Okay, so that's rotten oranges, and we're at 20 minutes. Dang, these problems are exhausting, man. It's pretty tough doing them like this. Okay. Another grid problem. This is another reason why too that I mentioned that this directions pattern is like so nice, because without going up, down, left, right in code is like so much more difficult without this thing, because you need like 4 different if statements or whatever and all that. With this, it just cleans it up into just one in a for loop. Okay. Pacific Atlantic water flow. There is a n by n regular island that borders both Pacific and Atlantic Ocean. The Pacific Ocean touches tiles on the top edges. Island is partitioned into a grid of squares. You are given n by n matrix. Heights above sea level. Island receives a lot of rain, and rainwater can flow to neighboring cells directly north, south, east, and west. If the neighboring cell height is less than or equal to the current cell's height, water can flow from any cell adjacent to the ocean. Return the 2D list of coordinates. RC. That denotes the rainwater flow. Oh god, this one's... I'm getting gassed, man. These problems are taking a toll on me. How much should we do? Like 6 minutes, 6 minutes, 6 minutes about on these? Cool thing too is I could probably finish this in an hour. Maybe, possibly, but... Rectangular... Okay, Pacific Ocean... Deals of coordinates... Where result denotes the rainwater. The rainwater can flow from cell. Okay, I understand. We want the points that can touch the Pacific and Atlantic, and the rule is that it has to be smaller than the value in order to actually flow or something. Rain can flow to neighboring cells north, south, east, west if the height is less than or equal to the current cell's height. So it has to be less than for it to flow. In this case, we can flow it because it flows here, 1, 1, and it flows here, 1, 1. Right, so it's able to touch both. And in this case, it's able to flow this way. It's also able to flow this way. But this 3 cannot flow and can't touch that one. So it's out. Oh, it looks like my screen froze for a second. Okay. Okay, so this problem is very similar to the one I just solved, I think, and also similar to the one before that, but this one's, I think, is DFS, because there's no kind of like limit. It's just kind of like anything, it feels like, which probably doesn't make a whole lot of sense, but like the other 2 problems seem to kind of have some kind of shortest path. Like this one's like shortest path. This one's just kind of like infecting everything with some kind of time limit. But shortest path, you're going to do BFS just generally, and then this infection type of thing is kind of like yeah, no, it's just time related. So if you want to track time, I also think like BFS can be useful for that. But for this one, it's not really. It's just like, is there a path? And when it's if there is a path that's like super general, it's like usually DFS because you're just checking everything to see if there's a path. Now in this case, so we would want to go. One thing I see is that we can just mark all the nodes that can touch the Pacific and the Atlantic. So like obviously this one touches Pacific. This one, yes, Pacific, Pacific, Pacific. And then we're like, oh, hold on, you're Pacific and Atlantic, and you're Pacific and Atlantic. So now we know like if something touches this, that we won, essentially. And we don't need to recompute all of that data. So we can have like some other grid possibly that just says like yes, like you are good, or yes or no, like you're not good, and we just check like you know, can you reach this one? It's like, oh yeah, well this one does touch it. Like I already know the 3 does touch a Pacific. So that means that like this one should. This might be kind of complicated though, but might be kind of complicated. Other idea too is just fill the graph out with all of the positions. Like still keep it, still have another graph here that lists out like these 2 sides. So this one would go like true, 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 true for Pacific side, and then like this one would go true, 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 true for Atlantic side. And then we just like kind of fill these out. And then DFS on all of them. And like start marking them. So this one is like, oh, are you bigger? Yes. Okay. Okay. Do you have anything bigger? Yes, you do. Okay, cool. Do you have anything bigger? Yes. Okay, mark it. Do you have anything? Yes. Okay, mark it. Yes, mark. Yes, mark. And we just kind of keep going for all the Pacifics and then all of the Atlantics. So this one is going to travel. And then maybe we just don't compute multiple times for Pacific. Yeah, that's probably, that solution works too, I think. No, the only problem is you're using extra space there, but I don't even know if, I don't think there's a better way that you can do that, honestly. It's the only issue is just using extra space. But we can code that out. Right, so define m and n, and then like, I guess, we can just have call it grid, I guess. And then it'll be composed of some tuples, which will look like false, false. Ooh, wait, but I don't want them as tuples. You can't really modify tuples. So it'll be false, false. And will look like 4 in m, and then like 4 underscore in or in range in range m. So this should replicate the graph, fill it up with falses, and then we just go through this. So 4i in range m, 4j in range n, and have a scene thing here in our set, and then we'll just say like if ij not in scene, like flip Pacific, or like flip values maybe, and then like is Pacific is true or something. So it'll be like ij, and then like if it is Pacific, then it'll be true. Maybe def like find. I don't know, I guess find partners. I don't know what you call this. Find partners or like move upstream. Move stream. I don't know what you call it, but like it was basically just take RC and then the like is Pacific. If we're moving from the Pacific side. Now curiously, I only want to run this. Let's see here, move stream. I only want to run this for the Pacific, which is going to be if I is 0. So this would be really, really cool, actually. This is very simple, actually, because I don't need to go through everything. I don't need to go through everything. I only need to go through this outer edge. So that's not bad. I don't think that's bad at all. How do you traverse through an outer edge of something? Row 0, iterate all the columns. Row -1, iterate all the columns. So just iterate all the columns. Iterate all the columns and then do one where it's m-1 and j, and then one where it's 0 and j. And then do the same thing, but for I, for m, I, and then n, or like 0, and then n, or I, and then n-1. Oh god, wait. I, n-1, I, 0. This should be fine. Only call it 4 times. And then do the magic, which is the directions array 0, 1, 1, 0, -1, 0, 0, -1. And then okay, what else is next? We've got do you want this, still want to add a scene for sure, and then just go through it. Yo, do you know a list of free mock interview platform? There is Pramp if you want to do mock interviews. So if you Jaguar Yoru, if you go to Pramp, they have mock interviews here. You have to sign in. I think they're attached to Exponent now too. All new Pramp sessions are hosted, but this is peer interview practice. It's honestly not that great. I mean, I'm not a super fan. What I would actually prefer is if you just ask people in like a community to do mock interviews. I think that's better. You probably get better results because a lot of people in Pramp don't know what they're doing at all and aren't very experienced. But again, I know you're in the school group, but if you post in the school group and ask somebody, hey, like, do you want to do mock interviews? Like, they'll totally do one, with you. Like, obviously, do exchange. But like, if you want to use a free platform, you don't want to, I mean, you could use Pramp. I don't think you're going to find like good study buddies and things like that. I think if you just go into Discord groups and talk to people, that you're going to have a better success. What would you recommend me to do if I don't have internship? Should I do project and Leetcode? Yeah, basically just project and Leetcode. Project and Leetcode, yeah. Build out like 2 solid projects if you want to get an internship or get a job. Yeah. Yeah. All right, let's go back into this. Okay, cool. So what we'll do is just want to move upstream. So then we'll do is say, do we flip it now? Yeah, let's do that. Flip grid at, ooh, but yeah, no, that's fine though. Grid at RC. And let's say like if is Pacific. That means that we're flipping the true part. So it'll be like true. Ooh, but that's kind of rough. Let's see left, right. I don't know. Left, right is grid RC. Left will definitely be true. And then just make it like left, right or something. It's kind of weird. Weird way of doing it. And then like else. Right, then we extract it, set it to true, and then set it back. That's what I like. Okay, and then go through here for dr, dc, and directions. nr is equal to 0. No, what is it? R plus dr and c is equal to c plus dc if 0 less or equal to nr less than m and 0 less than or equal to. Just check the bounds is in, and this is the big part. The grid at RC has to be greater than, because we're starting from here, this outer edge. This next node we jump to has to be greater than the other one. Has to be. So we need to be greater than. Does it say equal to? Greater than or equal to. Okay. So greater than or equal to that one, and it's grid at nr and c. If that is the case, then we can start our new DFS, and we can move stream at nr and c, and just pass in whether or not it's like Pacific or not. And one thing I didn't do is add it to scene. So scene.add rc to make sure we never visit that again. And we can even check if rc in scene, then we just return. And then we can immediately add it here. I think this is actually solves the problem for the most part. This will build out our grid, and then now we can just say like answer is this, and then we can loop through everything for I in range in. Yikes, why is this in? Oh no, that's fine. Okay, cool. For j in range in if grid at, let's see, like left, right in, or equal to grid at ij if left and right answer dot append ij, and then just return answer. Cool. Okay, yeah, I think this is like fine. This makes sense in my head. This makes sense in my head. Maybe I typoed, but n is not associated with a value. Lovely. Okay, we messed it up. I think this is fine, right? Like I thought it started with, I guess these are columns and then these are rows, maybe. No? Oh, wow, it sucks. That really sucks. Is it because I never called it? No, I did call it though. Oh boy, that's annoying. It's so annoying. What's my grid look like after doing this? No, it looks kind of beautiful. And the first one is all good. And it should be just moving on. Just move along. And it's only if the previous, right? So like here you'd say 1 goes here, 2 goes here, 2 can jump to here. Oh, wait. No, but 2 will always have the same jumping points. Once we're here, it will still jump here. It can jump here. This one can jump here. But it feels like these are missing, really. Like they're all false for the edges. Did I miss the edges? Or should I have painted the edges first? Because then we end up going all the way down like to here. And then we're like, oh, I've already seen this before. Yeah. Yeah, no, I think I see what I did wrong. I'm doing like something slightly wrong with this traversal. Okay, whatever. Dang, this problem is actually pretty difficult, I think. If I couldn't get it, I don't know. That's what I'm thinking. Hmm. Dang, and also it's like super exhausting, like trying to rush through all these problems, actually. And also talking through them though. That's like the hard part. Oh, also I think I'm gonna lose my streak pretty soon if I don't keep it up. Let's try and do this one. Given an array integer array, remove a subarray can be empty, such as the remaining elements are non-decreasing. Return length to the shortest subarray to remove, such that the shortest one to remove, such that the remaining elements are non-decreasing. So here we can remove 1042 because then it's non-decreasing. Non-decreasing. It does not decrease. Does not decrease. Doesn't decrease. What number can you remove so it doesn't decrease? Because this one isn't decreasing, but then it does decrease here, and it decreases here. So we got good, 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 bad. Once we found bad, we're gonna have to start removing 100%. So then we do remove, right? Is this one good? No, it's not. And actually you can't even compare it to this because we have to remove these. We have to compare it to the last one we saw, which is this 3. And then we're like, okay, remove. And then we're like, 3 is good. Is there only going to be 1 though? My guess is no. So this one we like say, okay, bad. So then we delete, delete, and then delete, delete. And this one's fine. It's something like that though. It's something with the solution is that like you just start growing until you find one that's bad. And then once you find one bad, you have to just keep on going until you find one that can save it. Let's see here, like last scene number. We can call it like, I guess math on infinity or something. Or is it negative math on infinity? And then we just go through for num in array if num is less than last seen num. Maybe flip a switch too. So like say like found decreasing. equal to false. Then found decreasing is equal to true. So let me go here, and then say, okay, we do find a decreasing one. So we continue for, or like while num less than last seen num answer plus equals 1. And enumerate like that. And go through loop if number is less than last seen number. If number is less than last seen number, found decreasing is true. Answer plus equals 1. Because we have to delete, we know we do once we see a decreasing, that's for sure. Don't know how many we would have to delete because you could just delete 1 here. We will delete the 10, and then we just compare this 3. And we're like, oh, 3 and 4 is good. But then this one actually ends up decreasing again. Ugh. So it's very strange. Is it some kind of window? Some kind of window? Like 10, okay, yeah, it's good. And then we go to 4, and then we go to 2, but then... Because now I'm thinking that maybe I can use like a deck here, like a doubly linked list, and then just pop from the stack or something when we see it. So we're like valid, 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 window is invalid, pop. Don't add it yet, but just pop this one, and then we can add this one, and we can keep going. And we're like, okay, no, this is invalid. Okay, so we have to pop that one too. And then we're like, is this one good now? Or do we need to keep popping? That might actually be it. It might not even be like a deck. It's just like a stack. A stack problem. And actually what we'll do is just keep it here, and then if stack and stack at -1 is greater than the current number, then answer plus equals 1 and stack dot pop. And we're actually going to keep this as a while loop too, while stack and stack at -1 is greater than num. That means it's non-decreasing. That means it's decreasing for sure. So we need to increment the answer. And then pop from. We actually might not even need this answer thing. You could probably do math based off the array, just total number of elements in the array minus what's in the stack, whatever the length of the stack is. But we do want to just adjust while this is invalid, and then just like return answer. I think this is probably the answer actually. We're like pretty close to it. So it looks like we're just off by 1 here, so. I think this is probably fine. No, it's not? Dang, that's crazy. Crazy, what? So here we're saying 1, 2, 3. We see a 10, which is fine. But then we see a 0. We're like, okay, well, we need to delete the 10. Oh no, but it goes deeper than that because you can't. You also have the choice of deleting the entire stack and just going completely clean. right? Because you get two options. You can delete all of these to accommodate this, or you could just delete this one. So you could delete this one or this one. Oof. I wonder how hard this problem is actually. Granted, I've only spent like 6 minutes on it though, but oh my god, it's a 1931. Kill me. Is it? No, this can't be. Yeah, it's a 1931. Jesus. It's a tough problem. Tough problem. Hmm. Yeah, okay, okay. Honestly, I'm probably not gonna be able to do this one. I said I think it might be DP. Probably a DP problem where again it feels like you're I don't even know what the answer to this one is. How is it two? But I think you can just delete the zero makes this terrible, so you have to delete zero. But and delete zero on the 10 is the best one. Delete zero on the 10. The thing is you just have two options at every time. I could just delete the zero or I could delete the 10. And I might prefer to go down each path, but if it's recursion, that's too many. That's not going to get it for 10 to the fifth, which makes this problem difficult. Um, and I can't think of anything else really though how to solve this. Because DP, I don't even like. I don't feel like DP doesn't work. I feel like DP doesn't work because you would only need in one state. You need one state. Maybe unless you're skipping indices or something. I don't know, but stack, add. And then pop or keep it and we just skip it. And that's it. Like, but that's so hard to keep track of. I don't think that works. Turing two pointer, binary search stack, monotonic stack. Yeah, it's rough. Binary search sliding window. DP greedy. Yeah, I don't know. Anyways, I'm gonna try to get this for the points, really. Try to get these points. Cool. Tough, 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 tough. Midnight Simon. The Midnight Simon. I'm waiting for you to drop that new website. I'm waiting for that website. I think I've showed it to like several people your algorithm topics to study. And like one person I think asked me oh wait, no, it wasn't one person. One Pat was struggling with line sweep and I was gonna like link a video because I'm pretty sure you recorded a video on actually how to do line sweep. Lots of work, yeah, I imagine. I bet. But I didn't, yeah. And then I think someone might have said something else either. Anyways, no, but a lot of people generally ask, like, this is a very common question. What algorithm topics should I know? And I just like send them to this page. You haven't uploaded it. Yeah, yeah, Pat didn't know how to do it or whatever. And someone was like, ask Simon. and then I like looked on your page to see if you had a video. Yeah, I'm working on making this list more fleshed out. Nice. Nice. I don't even, honestly, I don't even know. I looked on r/leetcode again because that problem comes up all the time. And I don't even know if anybody, like, what is it, like, which, like, algorithm patterns? Let's see if we can find this or something. Try to see if I can find it. Like, need top algorithm. This is 4 years ago, though. 6 months ago. Oh, here we go. 7 days ago. Is it best to focus on patterns? Oh, no, no, never mind. No. Well, I thought I saw. I've seen it several times here, but whatever. I don't know how it even comes up. If you looked at my Reddit history, you'd see it. Computer science and networks. Hello, buddy. Hello, buddy. Hello, buddy. Where the streaming stuff is exhausting, though. I don't know if it's because the streaming are just doing all the other work during the day. It's tough, man. Super tough. Super, super tough. I don't know what I'm going to be doing today. Don't have a faintest clue. And it's Friday. It's Friday, so I'm probably going to try to just chill. Work less hours than what I'm doing now. Let's see. What are we at? 1,199 for July 2023. And go to Hacker News. See what's up. Although Half-Life 2. Lusky is 1. Relativity. Oh my god. Why is my brain like just hurt? I probably just from staring at the screen. I don't know, but being on the camera is harder. I really, really wanted to do like just 6 hour streams. And I feel like I mean I could totally do it too. Like just live streaming my day to day because I don't have like an actual job or some corporation that's telling me like what I can and can't show. I could really go like full on open. Because I don't have Spotify. Easily convert Spotify links to your preferred streaming service. That's sick. I feel like Spotify doesn't do this. They make it so difficult for you to convert it. They hate the fact that like that you would go off their platform. I think they do that to make it as annoying as possible. Yeah, I'd probably stream all day if I didn't have a job. Yeah. Yeah, I thought about like doing it like just full on. I could totally just stream like just like everything really. Um because most of the time during the day, I'm just like trying to come up with video ideas or something or um or like if you really really like want to see like what I've been doing today is like I'm messaging people, so like DMing people. It's like a pretty maybe 30 minutes DMing people, and then like rehearsing like my sales script for like my business so that it comes out like super super fluid. Not super interesting, but if you're just like I mean I could literally just show all of that basically. Like it doesn't really I think it really matters, but um yeah, I'm also like running advertisements. I've been running advertisements and so I've been running meta ads actually specifically. And so like this is like my ads page or whatever. But like I'm like basically generating like the creatives for this. So like in each of these, like there's like ads for like my story or whatever. Like things that I'm just taking like interview things out or whatever. But anyways, I've been working on this today too. But it's just stuff I do off stream. But like I could like literally show all this stuff like for people who are I guess who are interested in business because I mean it's not has nothing to do with Leetcode. It's just like how do you run this stuff? Oh man, and this video is doing like so well at like $2 a conversion. This is amazing. $2 to get like kind of a result from advertisement. That's so cheap. It's unreal. And anyways, that's just ad stuff though, but ad stuff. This website's pretty cool though. Actually, I want to use this right now. So I want to convert my Spotify thing over and just like pop that in Apple Music or something or YouTube. I don't know. I don't use YouTube Music or whatever, but sick. Sick, sick. Wasn't that guy's quitting page on here? No. I don't even go on this website anymore. Bezos killed this. Matches catching up to genius. Rider is now free. I don't even know what the heck Rider is. M4 MacBook Pro. 16 days ago. We can now fix McDonald's ice cream machines. Can we? Why are those ice cream machines always down? Give me out of data. 2048 turn 10 this year. I built an updated version to celebrate it. Bro, this guy like popped off, man. I don't know if anyone actually played 2048 here, but like I actually want to say 10 years ago when he did make it. When was that? 26? No, it was I guess 2014. Yeah, that game was like so popular. I mean, in my high school classroom, so many people were just like sitting and playing it. It was really cool. It was a really cool game. What is it? Quit Google. There we go. This guy. I want to read this. Annual reviews. Customer is not your customer. That's kind of weird. I don't agree with that. I'm not sure I agree with this. The breaking projects, but also all there seems that they were only there for promotion. I mean, promotion is nice, but it was never really explained. Why is such a deal breaker? If the only thing keeping your job is a better profit title, it's probably a bad sign. Then they made a lifetime worth of money at Google in 4 years, and they use that to do something high risk, which most people can't afford to do. How will they use that stability? This feels like this person's like jealous. This person feels like they're jealous. Oh boy. I want to quit my job and try to do my own thing, but something tells me I should stay a bit longer. Yeah, you should definitely stay a bit longer for sure, I think. You should definitely stay a bit longer and just like do it on the side. This guy, like, he got like mad that he didn't get his Google promotion basically. For just a lot of stupid stuff. Like he worked really hard and like was like super smart, but like his project kept getting like canceled. So we worked on the project for 6 months. They canceled the project, and then he can't show any impact for his L5 interviews or his L5 promotion round. And so they didn't give it to him, so they skipped him over. And then before that, the year before that, he went for promotions and he didn't show enough impact or whatever by like just doing stupid stuff or whatever at Google. And so they passed him over again. They passed him over like before that, but this guy just kind of used the money that he had. Like, I mean, it's like you look at his finances, he posts them all actually, which is really, really cool that he does this. And I would actually totally recommend reading this because this is kind of like the reason like why I don't even like the corporate stuff. I can post the article here if you want to read it. If you, I don't know. But I read it on stream too, yesterday. But if you look at this guy's money, like you quit, you just make no money. Like just because it's a skill issue. Like you literally need to build all of the skills of having like a business. But like first year, this guy's making $2,000 in revenue. Like that is crazy. His first year. That's also honestly I think it's pretty sad too. I'm not sure what he was doing to generate $2,000 in revenue and then lose $23,000 on his business. That's crazy to me. But I think 2018 was probably maybe harder for entrepreneurs. I don't know, um, but then you look at his like second year. So if we go down here, so he gained $2,000 in the business, but negative 20,000 because he spent all like the business's money on hiring developers and stuff. So then he learned that lesson, and now he actually had a good year. He made $4,000. Like, yeah. Um, so still, again, I don't think he has like the skills, but it's like showing an upward trend. His third year, 3 years after quitting his Google job, and he's making now $63,000 in revenue. So he actually found like he did super well. He figured out what he was doing wrong and improved. But like profit wise, it's offset by like negative 67,000 in expenses. So the revenue is big and also the expenses are big. So like it's really he didn't earn anything. And he even breaks it down like the stuff he's building and all that. $46,000 in materials, $53,000 in sales, open source contributions. I don't know how this costs you money. Software development, order fulfillment, consulting with an electrical engineer because he decided to do a hardware thing or whatever. But yeah. But anyways, in his 6 year, 6 years later, like this is like where he's actually making like good money, and it's not even enough to replace his Google salary. So all that to say is that like I don't think it takes 6 years, but it does take a lot of time for sure. I think this guy's probably fooling around a little bit. I don't know if I got 3 years of runway. Yeah, yeah, yeah. So it's probably not worth it. I think you can get there in a year. You just have to do the right things. But I think this guy's just kind of marching at the beat, marching at the beat of his own drum. Um, but it's working out. Like I mean, obviously, like uh, he's right now he's at like 200K a year profit and $1 million revenue. It's a bigger increase, but I think it's just like a skill. You just have to build the skills, and then also like if you don't have those, or if you're not willing to spend the money, then you're just gonna spend time learning that all yourself. But all that to say, yeah, I wouldn't quit your job. I wouldn't do it. I mean, especially if you're chill there for sure. But one thing though that's kind of interesting, right? Like he can always go back to Google. But he actually just loves having his own business. And the same thing with me too. I love like just being able to work. Like I'm working like a lot of hours right now, but I really do like all of it. It's like way more fun, I think, than having an actual job. So yeah, that's that. Yeah, it's just more fun. It's fun, more fun and flexible. Although I'm working longer hours and making less money. What was that other guy? I want to see that comment. I want to see that comment. Yeah, Alder seems like they were there for promotion. Yeah, I think there's a lot of frustration when you're just like sitting in like a corporate environment. Like, I mean, I don't think the author was there only for promotion. I think he was just there so he could work and kind of grind up, I guess, the social ladder. And that's what it seems like actually. It was like directly for the social ladder. And I think he realized he just doesn't want to play that game, basically. Solaris and Midnight Simon. All right, I'm probably gonna dip soon. I think it's just been about an hour streaming. I waste a lot of time at work. I joke around a lot. Nice. The author here. Nice. I thought about asking this guy if I could do an interview with him. That would be cool. Because I maybe could. I could probably DM him. I don't think his following is like super super big where he's filled with people. I think he posts his Twitter here too. I could just DM him on Twitter or something. I might do it. You're just doing a mock tutoring session with me someday. What do you mean mock tutoring? What does that mean? What's a mock tutoring? Like a teaching you how to do a mock interview? Is that what you mean? Or do you mean giving you a mock interview? Oh no, I can teach you Segtree or something. Okay. Oh, so you teach me. Okay. Teaching me, yes, Segtree or Fenwick tree or some DP thing. Segtree would probably be more useful though, honestly. Um, sure, I think, sure. I don't know. I gotta figure out what my time is though. The problem is that like I'm not trying to focus on like doing like the competitive programming stuff, like learning Segtrees. Um, because right now like the bottleneck basically is the business side. But yeah, I'm sure I can we can go over that for sure. We can go over Segtrees, segment tree or yeah, yeah, whichever is easier I guess, or out of Fenwick or segment. We can do that. I gotta message you about I guess when we'll schedule it and when we'll do it. Quote the author to continue my career. I need projects that were. I'm not sure if he reflects like he'll admit the success of a startup. Relate on 100 factors how do you control it is never wasting time in your life. The success of a startup. Oh, author here. Yeah, I don't believe this also. Like, again, I think it's a skill issue. Like, having a business, it's 100% a skill issue. Like, the fact that it took him 6 years, it wasn't just like he randomly, like, luck boxed into it. I think you learn things along the way that, like, directly path. Yeah. I feel like if you're talking about a multi-million dollar startup, sure, but if you're just talking about making like 10K a month, like that's not luck. I don't think there's any luck about that. You, yeah, I don't know. That's my thoughts. Yeah, see, like this, it might be true at a high growth VC startup that you need many stars to align to succeed. If you're trying to make $1 billion company, yeah, sure, that's luck. But if you're just trying to make $5,000 a month, $10,000 a month, that's not luck. You basically just need one thing to see product market fit. Yeah, true. You just have a product that people want, then you just sell that to them, and like they're gonna want to buy it. You have all these control in the startup world. Yeah, I don't know, but I feel like most of the people here too, like they just don't have anything successful. They're probably just uh. It feels like the same thing too with like Leetcode. Like there's people who like think that Leetcode doesn't work for interviews, and then like they literally just give up. Like it's just like that. Like oh, Leetcode's just luck. Interviews are just luck. Well, like why bother? And then they do mental gymnastics to get themselves out of ever even trying it. Same thing too. I feel like it's actually with anything in life. It's like same thing with like dating. It feels like too, where you like you mental gymnastics your way. You're like, oh well, yeah, no, I'm too ugly. She'll never say yes, and like you just never try it. Oh, it's just like luck or whatever. Uh, really, I don't know. All these blog posts are always absolutely start by telling you that engineers are the smartest in the world. And his blog post didn't even do that. Oh my God, I need to get off the internet. Oh my God. This is so crazy. I'm just like seeing in real time, like people like just taking their own kind of like perceptions of the world and just like super hardcore, like just blasting it out. Wow. I don't, he doesn't say that ever in the article. Whatever. Whatever. All right, I'm gonna end stream. So it's been like an hour, and I'm getting tired of going on Hacker News. This thing is a little bit of cancer. Same thing too with Reddit. r/leetcode. All right, yeah, I'll see you guys later. See you Solaris. See you at midnight, Simon. If you're streaming today, good luck. Good luck.